All right, today we're going to be talking about Chapter 4, Exponential and Logarithmic Functions. Section 4.1 is talking about inverse functions. We're going to just first identify one-to-one functions, determine if something is one-to-one. When you do that with a list of ordered pairs, or if it was a mapping, or if it was a table or whatever, to be one-to-one, x can't be repeated, which makes it a function, but y cannot repeat. So to be one-to-one, meaning it goes both directions. Mainly one-to-one means it's a function in both directions. So if I was to switch the y's and make them an x, it needs to still be a function. And for that to happen, x can't repeat and y can't repeat. And that's all you got to do. So when I look at the x values, do any of the x values repeat? No. Does any of the y values repeat? No. So therefore, this function would be one-to-one. That's really all you have to do. So this would just be a yes. Good. So again, since x and y do not repeat, is it looking better over there? So when I did y'all's review, I was like, man, this is a lot smoother than trying. I think what it is when that transition from the Wi-Fi in this zone right here, it's like a big lag when I'm writing. Here, I don't think there's any lag. Okay, so since x and y do not repeat, it is 1, 2, 1. I'm also good with this notation as well. You did 1-to-1. All right, either way you want to work. Any questions on that one? Okay, let's move on to question 2. Wait, was there a question? Oh, I just assumed there wasn't, and I actually wasn't paying attention if anyone says yes. Sorry. All right, so let's look at a table. So let's say that we have 12.5, 5.75, 2.34, negative 12.7. Then we got 3.21, negative 4.5, 7.25, and 3.21. Is this one-to-one? Yes or no? Why? Because the y repeats. Very good. No, since y repeats at 3.21. By the way, on my test, and I'm sure just the homework, it's just simply going to ask you for yes or no. I'm writing the reason here so that you know why it's a yes or no. All right. Any questions on question 2? Yeah, you don't have to actually justify it to me. It's yes or no. All righty. All right. Let's look at a graph then and determine if it's one-to-one. Well, this section won't. Maybe the next section will. All right. When you're looking at it graphically, we have to determine A, is it a function? How do I know if a graph's a function? Does this pass the vertical line test? Yes. So remember, to be one-to-one, I should be able to switch my x and y values and it still be a function. So what that does, it allows us to use this thing called a horizontal line test. If I'm going to switch the x and the y, I'm just going to switch this over and do a vertical line test again. So in this concept, I can just do a horizontal line test. So does this pass a horizontal line test? Yes. So therefore, this graph is one-to-one. And do remember to pass a horizontal or vertical line test, it only goes to the graph one time. Right? If it goes through it more than once at any given point, it fails. All right. So any questions on determining if a graph is one-to-one? Okay. I go too fast, please let me know. I don't know. Is this number 4? Okay. What's the other? You said pink. All right. Is that 1-to-1? Yes or no? No. Why? Yes. Yeah, there should be something like, oh goodness. Yeah, there's something like that. So is that a does that I forgot the question now. Is this 1-to-1? No. It is no, but it's not because it looks weird. It fails the horizontal line test. If I'm able to draw a let's do a different color. If I draw a horizontal line test, don't know why I'm even tapping it because this is going to be a straight line anyways, but it will cross at least more than once at some point. Yes. Correct. There are functions, but they're not 1-to-1 because it fails the horizontal line test. So this would be a no. All right. Any questions on that? Awesome sauce. Let's look at one more graph before we move on. Is this 1-to-1? Yes or no? Why is it not? Good. It fails the vertical line test. Correct. Yes. The moment wasn't a function. There's not much more I can do after that. Yeah, I don't actually know what that equation would be. To me, it looks like a sine function that's been moved sideways, but I don't know how you can make a function to do that. But yeah, any questions there? All right. Nope. If I give you, I feel like an old man over here because I can't like see it very good. All right. So I still want you to determine if it's 1-to-1, but this time I'm going to give you a function. So I'm going to say h of x equals negative 3x plus 2. Give you a chance to write that down. All right, but to do this algebraically, no, it's a linear line. That's great. Algebraically, though, if a equals b, then f of bless you, then f of a equals f of b. Right. Basically, what you're trying to do is if I plug in a random number, do I only get one single number out? And is that one single number only equal one number that I plug in? And you could randomly choose points and stuff, but the math behind it is we're going to do this concept. We're going to set f of a equal to f of b and see if we get a equals b. If a equals anything other than b, it's a no. All right, so here we go. So this is going to be negative 3a plus 2. Again, replacing the left side of the x with an a equals negative 3b plus 2. All right? And we're going to solve this. I suggest just solve for one of the letters. I usually go with A, but you can go with B if you'd like. How would I solve for A? Good. Subtract 2 on both sides. Those should cancel. I'm going to go ahead and get rid of the parentheses. So that's going to make it negative 3A equals negative 3B. Then what would you do? Divide by negative 3. So does A equal B? Yes. that means that this is a one-to-one. Now, knowing that it's a linear function, it better be a yes, or we've done something wrong algebraically. Good there? In this directions here, it says use the definition. When it says that, that is when you got to use this. If the question simply just, okay, weird. If the question just said, is it one to one? Then yeah, if you know it's a linear function, you can say yes. But if it says use the definition to determine it's one to one, then you have to do it this process. Yes. Good question. All right, so another type. Q of x equals the absolute value of x minus 3. So if we know what this looks like graphically, should this be one to one? Yes or no? No. Why? It's a v and it's going to do what? It's going to fail the horizontal line test. So let's use the definition to prove this. So remember the definition, if a equals b, then f of a equals f of b. All right, so what we're going to do is we're going to plug in a, so we get the absolute value of a minus 3 equals, now plug in b, so that's now going to be the absolute value of b minus 3. Are we good on plugging it in and setting it up? Okay, what do we know about absolute values? It's going to good. It's going to equal a positive or a negative because absolute value of positive 3 is 3 and the absolute value of negative 3 is also 3. So what we're going to do is, again, just choose a letter you want to solve for. I like to go with A, but it doesn't matter. So that means that this A minus 3 has to equal B minus 3 or A minus 3 equals negative B minus 3. I don't know what B minus 3 is, but I need to equal the positive and negative version of that. So we're going to solve both of them, and it better be A equals B, or both A equals something, the same thing, at least. So what would you do to solve the first side? Add 3. And we do. We get A equals B. That's a good start. As long as I get A equals B on that side, I'm looking pretty good. What should I do first? Distribute. So I get A minus 3 equals negative B plus 3. Then what would I do? Add 3. And didn't cancel on that one. So I get negative B plus 6. Is that the same thing as B? No. So this is not one to one. All right. Questions on how to do that algebraically? All right. Objective 2. Three. Determine whether two functions are inverses. Whether. Determine whether two functions are inverses. So we have h of x equals 7x minus 3 and k of x equals x plus 3 over 7. So to determine if two functions are inverses of each other, here comes to this guy. So if I plug in f of x, or if I plug in, oh, well, let me just write it out and then I'll tell you. Does everyone know what that -1 is? What it means? I wish. That -1 means inverse. So if I plug in the inverse function of the original function and I get x out, you're halfway there. Because for it to be inverse of each other, I need to be able to go forwards and backwards. Meaning, if I plug in the original function into the inverse and also get x, now I know they are inverses of each other. All right. So this is the theorem. F of the inverse of x equals x, and the inverse of f of x also equals x. All right. Real fun stuff now. No longer looking at graphs and stuff. So what we're going to do is, it doesn't matter which one you do first. Take one of them, plug it in, then simplify. So what I'm going to do is I'm actually going to do h of k of x, meaning I'm going to take the k and I'm going to plug it in for x. So this becomes 7 parentheses x plus 3 over 7 minus 3. Yes, ma'am. You have to do both. Yeah, so you got to go either way with this. So it doesn't matter which one you want to do first. All right? Yeah. You got to show it. Okay. 7 times, if I multiply by 7 and divide by 7, what's going to happen? They cancel out, leaving me with x plus 3 minus 3. And then what's going to happen to the 3's? They cancel out, leaving me with x. Again, you might be able to see it just like that, but you have to show it at least a couple of steps. All right, so that's good. But now we got to go and determine. Oh, I like this green. Let's do this green. What does, oh, that's where I did that one. What is k of h of x? So this time I'm going to take the h function and I'm going to plug it into the k. So now this gives me 7x minus 3 plus 3, all divided by 7. Are we good on plugging things in? Okay. What's going to happen to the negative 3 and the plus 3? They cancel out, leaving me with 7x over 7. What 7's going to do? They go away. I'm left with x. Therefore, the answer is yes. Right? Questions on how to do that? It's not. It's just a lot of algebra. They both have to equal x. If nope. The moment you do it and you don't get x, you can just stop. Now, there are certain situations where it's an inverse on one side, but it doesn't go the other direction. All right, so let's look at another example. So let's, this is number 9. So we'll say P of x equals negative 3 plus x over 4. And Q of x equals 4x minus 3. Right. Doesn't matter which way you go. Brown. P of Q of x. That's the direction I'm going. Doesn't matter. So I'm going to plug in my Q in for my x. So I get negative 3 plus 4x minus 3 over 4. Now we're going to simplify. I can combine my constants. So negative 3 minus 3 gives me what? So I get 4x minus 6 over 4. Now, you could separate these two problems. 4x divided by 4 is just 1x, but negative 6 divided by 4 gives me what? 3 over 2. Did I get x? No, so I can stop right there and just say, no, there's no need to prove the other side. All right? Now, if you did the other side and got x, then maybe on this side you saw that it was not x. It depends on which direction you go. Questions on that? No, they both have to be x. Mm-hmm. It can, yes. Yeah. Now you can do one, go X, and then a lot of students will go, okay, if it's yes, and they won't try the other side and realize it fails. So watch out for that. All right. Any questions on objective 2 then? All right, let's go to objective 3. Hmm? Yeah, well, I don't know. After going through Unit 3 and seeing how much was in it, Unit 3 might have been hard. But I don't think it was hard in a sense like it was hard. It was a lot in that chapter. So I think next semester I'm definitely going to assembly and yes, yes. Yeah, so that was not good. It was just a lot. Okay. So objective 3, we're going to find the inverse of a function now. Now that you know how to determine if something is a has an inverse, if something is an inverse of each other, now how do you actually go find the inverse? All right, so here's the first question. Number 10. Let's do this one. Okay, so n of x equals 2x cubed minus 5. Oh, really? See, it's a delay. All right. I think it's like 4 steps. I don't remember. We'll count them out together. Step 1, switch your x and your y. Remember that n of x is a fancy way of saying what? Y. So we're going to switch x and y. So this is now going to be x equals 2y cubed minus 5. That's step 1. Switch x and y. Switch x and y. Okay. Now solve for y. This might take multiple steps, but this is the second step. So what would you do first to solve for y? Add 5. Good. So we get x plus 5 equals 2y cubed. Oh, I forgot to also say, in the directions, it will say this function is 1-to-1. Go find the inverse. Because you can argue if it doesn't say that, maybe it doesn't have an inverse at all. So the directions in the homework and on the book, it says this is a 1-to-1 function. So therefore, there is an inverse. What is it? Okay. All right. What would you do next? Okay. When I do that, I then get x plus 5 all divided by 2 equals y cubed. You can separate those if you would like, or you can write it as one gigantic fraction. I think it looks cleaner this way, but it doesn't matter to me. All right, then what? Cube root it. Very good. So I'm going to cube root both sides. So therefore, I get the cube root of x plus 5 over 2 equals y. It is. But any questions on that? Third step. Super easy. Change y to the inverse notation. So in this case, it'd be n negative 1 of x. So this becomes n negative 1 of x equals what you just solved. So that is the correct answer. You have to show the negative 1, indicating that this guy is the inverse of the original guy. Questions? Concerns? All right, let's just practice until the class runs out then. Let's try this one. Oh, this is number 11. So we have v of x equals x minus 5 over x plus 1. Give you a chance to write that down. Again, the directions say it is 1-to-1. What's its inverse? You ready? Yes, very good. So step 1 was to switch x and y. So this now becomes x equals y minus 5 over y plus 1. Bless you. What's your thought process on trying to solve for y? That's okay. So what would you do first? What would you multiply? By the denominator. Let's just get rid of the denominator. Now remember, this is a rational function in which we can just cross multiply. So we get y plus 1 times x. I'm going to go ahead and distribute that. So I'm going to say x times y is xy. X times 1 is x. 1 times that's just itself. Okay. The goal is to solve for y. So I need to get it to a point where there's only one singular y. Now, this is a great concept because you do this in differentiation when you get into calculus. But the goal is, after this point, is to get all terms that have a y on one side and all terms that don't have a y on the other side. All right, so I notice I have a lonely y over here. I'm going to move it to this side with the other xy. And I see that I have a lonely x that does not have a y. I'm going to move it to the other side. So I'm going to subtract y on both sides, and I'm going to subtract x on both sides. All right, so that goes away. I now have negative x minus 5 on this side, and those cancel out. So then I have xy minus y. I cannot combine those because one has an x, one does not. Not yet. You get the idea of dividing. However, to get this to turn into one singular y, what do these two terms have in common? A y. And if something's in common, I can do what? I can factor it out. So now I'm going to factor out the I'm going to factor out this y. So that gives me y. And then what am I left with? Very good. X minus 1, which equals negative x minus 5. I now have one singular y. How can I get y by itself? Good. Divide that binomial, or whatever this polynomial is, to the other side. So I now get y equals negative x minus 5 divided by x minus 1. What's the final step? I got to write the correct notation. So that y will turn into a what? V negative 1 for the inverse. And then I just rewrite the question or the answer. Questions on those? Nope, you can't cancel out the x's, can't do anything with the negatives or anything like that. And the reason you can't is because this is a minus 5, so that's attached, and this is a minus 1, which is attached. It'd be different if it was like x times negative 5 or x times negative 1, then I could cancel out the x's. But because it's a subtraction or addition, I cannot cancel them unless they're exactly the same. Questions? Let's do some more. We got time. Let's get more complicated. I want a different color. Sounds great. Did you see purple? It won't let me select it. It's going to just let me just get brown. Go back to pen. Oh, I guess you can't change the color of the eraser. Would you call that purple? Light purple. Okay, okay. Lavender, that's what I would call it. All right, so number 12. You sure that's not too light? Oh, y'all see it really good. It's really pale on this side. All right. Let's ask one of those questions that y'all love that has 22 parts on it. Soothing. All right. So part A tells us to graph f of x equal to x squared plus 1, semicolon, x less than or equal to 0. What that is stating, what kind of function is this? Semicolon, semicolon. What do we know that function is? It's a quadratic, which makes a parabola, which we know is not 1-to-1. But then it gives us a restriction and says x less than or equal to 0. So that means I cut my graph in half, and now I only have half of one. Does that pass the 1-to-1 graph? Yeah, so that's why it's making us do this. I think we definitely did inverses in algebra 2, so you probably saw it then. Probably saw it on the SAT even. All right, so let's graph it. So here we go. So I'm going to plug in 0, which is the breaking number. 0 squared plus 1 is what? 1. So I'm going to go to 1, and I'm going to put a dot there. And then it's all numbers less than that. So let's choose -1. What's -1 squared? 1 plus 1, 2. So at -1, I went up to 2. And choose -2. What's -2 squared? Plus 1, 5. So that's so something like that. And we get something like that eventually in a better drawing, right? But it says half a parabola. Now you can make as many points as you want until you feel confident on what the shape looks like. But knowing that it's half a U, make sure it's curved and not a straight line. All right, so we got the graph. Then part B then states, from the graph of F, is F a 1-to-1? So is F 1-to-1? Yes or no? Right now it is, right? So we would say yes, right? And it's because it passes the vertical and horizontal line test. So we're good there, right? Part C states, write the domain. So what's the domain? Perfect. -infinity to 0. What goes around them? Parentheses and a bracket. Very good. Any questions on domain? All righty. Part D. What is the range? Perfect. What's the symbols that go around it? Good. Bracket and a parentheses. Be weird to put another infinity sign there. We'll go on domain and range. All righty. Part E. Write an equation for the inverse. So now they want us to go find the inverse of this guy. How would I do that? Let's step 1. Good. Switch the x and the y. So this now becomes x equals y squared plus 1. What would you solve? -1. So I get x minus 1 equals y squared. Then what? Square root it. Now, typically when we take the square root of something, it's a what? Positive or negative. It's a plus or a minus. But because we are talking about the negative x's, this will just be a negative answer. Okay. So because the domain's restriction limited us to the negative side, that would then mean that my inverse will only have the negative side. And then the last step is to do what? Write the inverse notation. Very good. Don't forget that step. It's going to be sad if I have to take a point off because you did all the work and forgot the symbol. All right, so we're good on part E. Okay, then we move on to part F. H. Now it wants us to graph this guy on there. So we're going to graph. I don't know how to spell graph. Yeah, that's what I was trying to do. H of inverse. All right. I think I'm going to do a different color now. What we like? This one? Dark red? Oh. All right, so when I plug in numbers, again, our restriction is x is less, well, actually, doesn't specify. Okay, I like that. Um, okay, this is a good teaching moment. To be an inverse, how did I find the equation? What was step 1? I switched my x and my y, and then I solved for my y. Same concept. If I gave you a table and I wanted to know what the inverse value of those tables would be, you would do what? Switch in your x values and you'd be done. Same concept when it comes to your domain and range. If your function of your domain and range is this and this, the inverse would literally just switch it. So now the domain of the original function is the range of your inverse function. and the is the domain of the new one. So I'm actually going to skip to the next two questions here because it'll help us graph it. But part G says, what's the domain of the inverse? And knowing what I just told you, what's the domain? Very good. All right. It is, but I wrote h of x instead. But yes, h, what is the range? Very good. All right, and I skipped f to do those two to make it a little bit easier. Since I know this is my domain, I'm going to plug these values into my inverse to see what the graph looks like. So I'm going to start at 1 and then all numbers greater than 1. So if I plug in 1, what's 1 minus 1? 0, the square root of 0, and then negative 0, 0, right? So if I plug in 1, so the x, so whew, where are we at? Here's 1, and then it's at 0. So 1 comma 0. There's my point. There's space between there, yeah. Yeah, there's a gap there. This is 0, this is 0, 1, this is 1, 0. Basically switches the x and y's. Blah 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 blah. I could technically. Oh, there's two different ways to do this now. I could take 2, plug it in. 2 minus 1 is 1. Square root of 1 is 1, and then negative 1 becomes negative 1, right? So 2, negative 1. Here's my new graph. I could take this coordinate, which is negative 1 comma 2, and flip it, and now it becomes 2 comma negative 1. So you can either take the original points and flip them or do the math. It doesn't matter. So like if I took this one, this is 2 comma, or sorry, negative 2 comma 5. That means if I flip it, it would be 5 comma negative 2, giving me a graph that looks something like that. It's actually half of a hyperbola. Yeah. Pretty cool stuff, huh? Yeah, you can still plug it in, but the issue is, and here's where you're going to fall. If I was to plug in 3, I get 3 minus 1, which is the square root of 2. Then I'm trying to figure out, all right, square root of 2 is between 1 and 2, and the decimals here. And it'll give you a good point, right? But so that's what I'm stating is it take nice points here, flip them, and then just graph them with, so you're not having to try to figure out, all right, what number will give me a clean number. But both techniques work. You do whatever you like. Questions on stuff like that? All right, we get out what, 41? All right, let's just do one more and then we can call it a day. I think we've done enough practice for today. All right, so I'll let you kind of play with it at first. Part A says to graph f of x equals the square root of x minus 2, no restrictions. And then I'll just write the rest of the questions while you work on it. Mm-hmm. It's like that check mark looking thing. I'm going to put a bonus question down here for you. Let me know when you're ready. All right, we got about 3 minutes. You want me to go ahead and kind of go over them? See how we did? All righty. So if I plug in, it doesn't matter where you start. Actually, it kind of does. Start with 2, right? Because if I plug in 0, what's going to happen? You get a negative, and we can't graph i's. You plug in 1, you get a negative, we can't graph i's. So if we start with 2, we get 0. And then I can choose like 3. 3 minus 2 is 1. Square root of 1 is 1. 6, because I'll give you 4. So 6 minus 2 is 4. Square root of 4 is good. So we have a function kind of like that, right? So it kind of stops there. Perfect. Is that 1-to-1? Yes or no? Yes. Very good. What is the domain of this guy? Very good. What is the range of this guy? Perfect. All right, let's find the inverse here. What do I do first? Okay, so I get what? Perfect. Then what? Square both sides. Very good. That gives me x squared equals y minus 2, because those would cancel. Then add 2. So I get x squared plus 2 equals y. Whew. And then you got to fill in the inverse. So I get inverse x squared plus 2. All right. This kind of goes into the bonus question. Well, I'll tell you what. Before we get into the bonus question, before we even graph, what's the domain of my inverse? Which is bracket, yeah. And then this would just be 2 bracket infinity. All right. So my question is why is there a restriction of x greater than or equal to 0 in place of the domain of my inverse? I know this is a quadratic. It should be a U shape, but why is my domain 0 to infinity? Why does it have to be positive? Okay, it would fail the horizontal line test and wouldn't be 1 to 1. But why is it that I have to put this restriction on it? Right. If you look at the original function, since the range is going to be the domain of my original function, that's going to limit me on whatever graph that I get. So since the range was 0 to infinity and my domain will be 0 to infinity, that's the only portion I would graph. Even though I know the domain is all real numbers in a quadratic, because of the range limitations on the original function, it limits the domain of my inverse. All right, so that when therefore when you graph this, let's see, that was 2 comma 0, so it's 0 comma 2, 3 comma 1 would be 1 comma 3, right? 3 comma 1. Yeah. And then I guess you're leaving. Yeah, have a good day. You too. Yeah, I got this. Actually looks like something like that eventually. Have a good one. Enjoy y'all's weekend.